Hello, everyone. Buenos días, bon dia. My name is Vicente, and I'm a software engineer manager at Delivery Hero, and I will show you basically what my team has been doing for the last 1.5 years. Basically, we've been building a data pipeline in order for data consumers within the company to consume the data in real time, also in other two ways. I'll show you in a couple of slides, but our main focus was the real time. Okay, so some key facts about the company, just to understand what's the business environment. So Delivery Hero was founded in 2011, operating in 40+ markets and employing more than 70,000 people. It's the largest food network in the world of the apps, with more than 200,000 restaurants online. It went public in 2017, and in 2018 reached the 1 million orders in one day. And as per July this year, we processed more than 2 million orders on a single day. Now in regards of data. So in Delivery Hero, only for order-related events or data, we are processing per day more than 2 million events. On top of that, you have to add the user data, the vendor updates, logistics the information, so many more events. So as you can imagine, it's a business operating in quite a lot of markets and with a decent amount of volume to process. Also to understand how the company is organized, and that will lead to why our team started. One way of grouping Delivery Hero is there are on one side the brands that are teams building services that deliver the food to the customers, that get the orders from the customers. And there are many brands around the world, or quite some. For instance, Foodpanda is operating in APAC, Europe, Miam in Austria, Talabat in Middle East. And these different brands have their own tech teams with their own databases, with their own ways of defining what's an order. And they don't relate to each other, right? They are different type of information. And on the other hand, we have global services, something that you can imagine as a micro or macro service that provides functionality for these brands. So for instance, we have a logistics global service, we have a recommendations global service, we have a search, and they are independent, right? An order in logistics is completely different than an order in Foodpanda, and so on. So then what's the challenge of this approach? The challenge is that if Foodpanda wants to integrate or use search and logistics, and search and logistics needs the order, then Foodpanda has to send the order as it understands the order to these two services, right? If Pedidos Ya, a brand operating in South America, wants to also use these three services, the same has to happen again, right? So it's, again, another connection, sending the data, maybe in different format, to these services, and so on. So you can imagine that we are replicating several clients around the network. They are sending maybe same data to different services at the same time, and that's why we started our team, and we started building data fleets. It's how we call our data pipeline. And then what's the mission of data fleets? Our mission was to unify the data across all these brands, to provide then this data in at least 3 different ways: in a real-time manner, in a low-latency RESTful API, so the consumers could pull this data, and also in a high-latency or maybe analytical processing way in which the consumers maybe could run analytical queries and process this data. And obviously, given that we have already the data unified in data fleets, it makes sense to also build machine learning applications on top of that, because then the machine learning teams don't need to write algorithms for each of these orders from each of these brands, and they can just run the algorithm to work based on singular model, and it's more efficient in the end. So, what's the architecture that we went for data fleet? So, any producer will send the data to an ingestion API. So, the data will be in certain format and will be valid. Then it will be pushed to the streaming part, streaming service. And from the streaming service, there will be different event subscriptions, one for the real-time consumers. There will be another subscription for storing these events in the storage that is needed for the low-latency API. And there will be another subscription in order to store this data in a database that can process these analytical queries. So one ingestion point for any of the brands, and 3 different ways that we can provide to the consumers to consume this data. Okay, let's start with the first component. So the ingestion API, very simple. Just we are using API Gateway and Lambda. You will see that we are using a lot of AWS components, but I will try to give an analogy with open source components. So API Gateway and Lambda is just an abstraction of maybe some RESTful API, basically, that you can run open source. So what's the mission or why we have this ingestion API is to make sure that the data follows certain schema and that the data is valid, basically. So because as I said, the order events from the different brands are different, so we need to make sure that they are the same. So at ingestion, we verify. They have to send the data in the format that we specify. And besides ingesting the data for the real-time events, we also provide, or we also use this ingestion API for doing a sync of the data. So if they want to send all the restaurants for certain country, they can also do it from one of these endpoints. And we use, for security and authorization, we use IP whitelisting and JWT, nothing very fancy. Now, in regards of the deployment, because I think this is a bit interesting. So we are using Canary deployment that is provided by Amazon. And the reason to doing so is in order to reduce the amount of data loss. The way we are deploying it is every time we have a release for our ingestion API, we start rolling out traffic to this new release and checking metrics in the meantime. And that allows us to reduce the amount of data loss if we will deploy a wrong release on production. Or if we would deploy a release that we think the data will be fine in the environment, in the production environment, and that's not the case. So that's why Canary deployment, we decided to go for Canary deployment. So we deploy a new release, and we start routing traffic to it, checking the metrics, giving more traffic, and in the end, giving the 100%. If something goes wrong, then we roll back. Okay, now the streaming part of the architecture box. So once the data is on the ingestion API, the Lambda writes the data into Kinesis. AWS Kinesis is same as Kafka. Why we use Kinesis? Because we can have as a storage, can use it as a storage in case some data is lost on the downstream side. So Kinesis allows us to store data for 7 days, and we can replay it if something goes wrong. And also Kinesis scales up and down, so that's not an issue. From Kinesis, now we have a Lambda that is reading from there and pushing to SNS. SNS is a message bus provided by Amazon. I don't think there is good analogy on the open source. Maybe PubSub on Google Cloud, maybe PubNub on other services, but it's basically you push a message to it, and if there is any consumer subscribed to this topic, SNS will push to the consumer, basically. And then the consumers on the SNS side. So you might wonder why we have Kinesis and SNS. Why the consumers are not just reading from Kinesis, as many of the services I have seen. The first reason is, first of all, we don't care about the order of the events. It's something that the consumers have to deal with it. As I showed you, there is an Ingestion API, and the clients are multi-thread clients. They are pushing the data in parallel via HTTP requests, and things and events can come out of order. So the fact that Kinesis ensures order is already gone by the fact that we have a HTTP endpoint on top of it. The good thing about SNS then is because we have, SNS provides you out-of-the-box message filtering. So if there is a consumer that is only interested in orders for Canada, we can, on Kinesis, configure the subscription for this consumer to only receive orders for this type of events following these message attributes. So they don't have to care about the fact that we have 10 million order events. Maybe for Canada it's just 1,000, and maybe they will only receive the load for 1,000. So it reduces the complexity on the consumer part. Another fact for choosing SNS is because scaling up Kinesis is harder, or you have to scale Kinesis as the amount of consumers grow in order to make sure that the throughput is at certain level. So the more consumers you add, the throughput is divided, right? And then you have to add more shards to the Kinesis in order to keep up with the certain throughput. And this doesn't happen with SNS, basically. And the third or the last reason why we decided to choose SNS is because it allows us to provide to the consumers two different ways of consuming the data, push and pull. Push via HTTPS, so we can create a subscription on SNS, and whenever we push a message to the SNS, SNS will send HTTP requests to the consumer, or pull using SQS, is like a queue, same as RabbitMQ or other queues that exist on the open source. So whenever we push a message to SNS, if the subscription is with SQS, SNS will write the message into the queue, and the consumer will pull from the queue whenever they want. This is just a summary of it. So SNS, HTTPS push, SNS, SQS pull. So how we do stream aggregation, or I saw also on a previous slide, it was called enrichment. Actually, what we are doing here is more close to enrichment. What we call by enrichment or stream aggregation is just joining two streams. So imagine we have on one side one topic, two topics, one for order events, so when an order is placed, another topic for order status events, when the status of the order changes, right? We have two topics. Let's imagine that now we have a consumer that wants to consume data that combines both. So whenever we have an order status event, they want to also have the order event, right? That would be the SNS topic on the right side. So how we implement it on our case is for every order event we get into the topic, we have a Lambda listening to this SNS and storing the order with the reference order ID on DynamoDB. DynamoDB is a NoSQL database, same as MongoDB. And the good part of DynamoDB is that it scales up automatically up to the reads and writes you want. So it's very convenient for us. So order reaches the SNS, Lambda writes into DynamoDB. Now, whenever we have an order status event on SNS, we store on SQS, and from there, it's a queue, the queue, and from there we have a Lambda reading the message from this queue, checking if we have this order on DynamoDB. If we have it, we combine the event and we push to this topic. If we don't have it, this Lambda can take back the event on the queue and reprocess in several seconds or minutes. The reason for this is because we have to deal with the fact that things might come out of order. So it might be that we might have an order status event, but we still don't have an order because it didn't come. So that's the reason for using the queue. Okay, now the other capability that we had to implement is to allow consumers to pull the data via REST interface. How we implement it? Very simple. We have already the SNS topic. We trigger a Lambda. We store the data in DynamoDB that I already told you that scales automatically. And on top of it, we just put API gateway endpoint to read from there. We have a queue called dead letter queue in the Amazon terminology in order to have retries in case there might be some network issue or things like that. So it's used in order to have a higher consistency in case things go wrong. So this, by using these components, we don't have to scale anything. This works if you have 10 events or if you have 10 million events. It will just be processed. Obviously, you will have to pay more to Amazon. They will be happy, but at least you will be happy as well because you will not have downtimes and things just run. Okay, now the last capability, the analytical capability. So as I told you, is we needed to allow basically our consumers to run queries that will analyze huge amount of data. So typically, we will need an all-app DB, right? What we decided to use is Google BigQuery because it scales automatically. Basically, it doesn't scale, you don't know. It's just the interface for your consumers to run these analytical queries. Google BigQuery will just handle it, regardless if you have 10 megabytes or 100 terabytes. You will just pay for that. How we implement it is, again, we have the event on the SNS pipeline, and then we have a Lambda reading from there, and then pushing the event to BigQuery, using the BigQuery streaming API, very simple. And again, having the letter queue in case maybe BigQuery might have issues or some network things and so on. So just to make sure that the consistency of the data will be high and that there will be no data loss. So again, by using these components, that doesn't matter the volume of your data. This just scales up automatically. Okay. We also use BigQuery for data visualization, of course. The fact that we have already all the events there, it also allows us to use Looker or Data Studio or any of these, or Tableau, or any of these technologies that build reports on top of your data. Okay, so to wrap it up, on the top of the slide, we have the producer sending the data to Ingestion API. From there, the data reaches the streaming part that gets the data into SNS, and then from SNS, we can provide data in 3 different ways. First use case, near real-time with push-pull. Second use case is providing a RESTful API for the consumers that don't want to have the data, they just want to pull it. And the third use case is for these teams that want to analyze huge amount of data. Our tech stack is nothing really fancy. I already mentioned the data management solutions in the middle, but on the backend we use for programming languages Java and TypeScript, GitHub, Travis, Slack, Jira, nothing fancy. CloudWatch X-Ray. X-Ray is the APM for Lambda. You can also use Datadog. We might use Datadog for the CloudWatch logs, and the Strike driver on the Google Cloud side. On the infra side, we use Terraform to deploy our infrastructure in Amazon and Google at the same time. As of a few weeks ago, we started using Atlantis. It's this island icon you see. We use it in order to deploy Terraform from GitHub, basically. It's very nice. It provides you a very nice output of the changes on every pull request. So if you are using Terraform and if you are not using Atlantis, please take a look. It's really cool. So what are the challenges that we have faced during this 1 year and a half? First of all is defining SLAs. So the fact that we use cloud services and the fact that they don't provide SLAs for the latency or the durability means that we cannot do it, right? Because we are using them. What we have done is we created a service that is pushing data on staging and production, and then dummy data, of course, and then from there, measuring what's the latency if there is any data loss, and then based on historical metrics for these things, then we can ensure at some certain level what's the latency of the whole pipeline, or if there is any data loss, basically. So we are instrumenting ourselves. Second challenge is the data quality. So the fact that we have an API endpoint that is ensuring that the data is following certain schema and is valid, because we have constraints like maybe email, phone number, and things like that. So we have to ensure that this data is valid, but at the same time might be that the data is rejected. So how to find a balance between rejecting data and having some data that is partially invalid. So that was one of the challenges. At the moment, we are just logging and creating reports and all. That is a challenge we face. Another challenge is the data documentation. By this, I mean having a proper tool that exposes what's the meaning of our data, what data we have, how this data is linked to data on other teams. So typically metadata. There are open source solutions that, like Apache Atlas or Amazon and Google, they provide their own. We decided to use Apache Atlas, the open source one, because it's has more features. And what we are doing is we are exporting BigQuery metadata, so the tables, the columns, the type of the columns, if they have descriptions on the metadata, we import that into Atlas, and we provide this as a UI for the teams using our data. And Atlas, if we import also metadata from other teams, Atlas could also link our data with others' data. So this might also optimize the time spent by your data engineers searching for the data, trying to understand it and all. Third challenge, GDPR, of course. I don't think I need to explain more. You have to be compliant, is the law. Fourth one, automating new pipeline. So the fact that we have such distributed architecture with so many components and all makes it harder to create new pipelines from the scratch. It's same as with a microservice architecture. So the more components you have, the harder it is to create them. And the last one is automating SNS subscriptions. So also how to deal with so many consumers, with managing the filters, how to deal with these kind of things that take, in the end, effort from our side, and we want to automate these type of things as much as possible. That's it. We are hiring. We are a team of 5 engineers. So if this is of your interest, please send your application or talk to me. That's it. I'll be now answering to your questions, and I guess there will be office hours as well. So yeah, thank you.
Hi. I have a question regarding the database. Why you haven't choose Redshift or Athena, given that you are everything is on AWS?
Yeah, good question. First of all, because Redshift doesn't scale automatically, so you will have to assign the nodes and have this headache, or maybe wake up in the middle of the night because TTLs broke the cluster. And why not Athena, which is more serverless, because it doesn't provide capabilities for updating and deleting the data, which are needed for GDPR. It's not that it doesn't provide it, you have to implement it, basically. It's not that Athena provides you update or delete SQL queries.
Hi, nice demonstration of your process. I see that every procedure, I mean, it's very clear you are utilizing or processing huge amount of data. I also see that in each one of your procedure or process, I see AWS Lambda as common element, right?
Yep.
But Lambda has its own constraints, like memory constraint, time constraints. has Lambda been never an issue, these time and memory constraints, an issue for you in any of the process?
No. I don't know. For us, it's running smoothly.
Have you considered
There are, of course, hard limits.
Yeah.
Like if you have a very huge amount of, a huge spike of load, Lambda has some limits in that sense. But same as if you are running your cluster, right? If you are running your cluster and you have huge spike, your cluster doesn't scale in microseconds, right? Or milliseconds, even on seconds. So.
Hi, nice presentation. Thank you. How was your decision process to choose the use of all this cloud infrastructure or cloud services actually versus rolling out your own? Like it's using Kinesis instead of Kafka, using Lambda instead of some, I don't know, hosted processor, streaming processing engines. Yeah, the reason is that given that we use cloud services, then we use these cloud applications or tools because it's less headache in the end to maintain. So for us, scaling up Kinesis is just updating one value, and then Amazon deals with the resharding, keeping with the nodes running while resharding, making sure that the resharding is not in an endless loop. And these type of things that I heard from, for example, on the previous presentation, is something you don't have to deal with if you are using Kinesis, for instance. Something that Amazon is already doing it for you. Yeah, so we try to use these cloud tools as much as possible because of the advantages that brings. In some cases, it might be a limitation. Maybe you want to, there is a hard limit on Kinesis. For example, storing the data for more than 7 days. That's a hard limit. If your Kafka, if you need to store the data in the event source database for more than 7 days, then you need something else. One of the points you explained was about SLAs and how to reach them, especially for latency. And I thought that was a particular point where you could have your own saying if you were running infrastructure versus using their service. Interesting. Thank you.
Yeah, thanks for the presentation. I just was triggered by one of the things that you said, that you're not caring about order, and especially with the ladder queues, you might have like some messages that are quite delayed. I was wondering if like the consumers of the data ever had any problems around dealing with the lack of order.
Yeah, so we are monitoring the delay of the events. So we are receiving on the event the timestamp when the event was generated. We are checking what's the delay between when the event reached our tool versus when the platform said that it happened, basically. So we are at the moment just doing a soft monitoring, but we can easily create alerts and things around that. Yeah.
Hi. Do you have any additional comments regarding the data transfer costs between AWS and Google Cloud? Because is the amount of data not that big, or because for us that was the main blocker to use to switch between to use like both cloud providers?
For us at the moment, it's not an issue, but as soon as we see on our infra cost that we are paying huge amount of money for this, we might think about it. I think it's also how you have negotiated with Amazon, these kind of things, or Google, or both. And I'm not aware, but at least on our infra cost, it's not huge.
Hello, great talk. So for example, you were mentioning about quality checks, complex validation, how you use API Gateway for that. You also mentioned about the different brands that you end up supporting. So how do you handle, for example, custom data that specific brands still want to do reporting on that does not align to your sort of core message model?
Yeah. On that case, we just add it as optional, obviously. If there is piece of information that is needed for some consumers that is only produced in Korea by Yogiyo, and not in Europe, then we just add it as optional field.